Since Biden took office, the U.S. government has implemented a series of bills to suppress China in the fields of trade and technology. Anyone with a discerning eye can clearly see that these bills clearly violate the logic of market economy. So why does the Biden administration continue to implement it regardless? The recent resignation of a White House advisor may explain this problem. According to Global Network, the U.S. political website recently confirmed that Ronnie Chatterjee, an Indian-American advisor to the White House and the author of the Chip and Science Bill, announced his resignation after serving in the Biden administration for 2 years and returned to teach at Duke University. Chatterjee did not disclose why he resigned, but political website analysts believe that the failure of the chip bill is likely to be an important reason for Chatterjee's sudden resignation. Ronitsa is one of 130 Indian White House advisors and government officials appointed by Biden after taking office. In the past, he was a professor of business policy at Duke University and served as a senior economics advisor in the Obama administration. It should be said that Chatterjee did show a certain level of professionalism, at least when it came to dealing with China's internal issues in the United States. After being appointed as a White House advisor by Biden, the first big thing he took over was to deal with congestion at U.S. ports in 2021. Chatterjee handled this tricky task well, working with the U.S. Department of Transportation and commercial companies. Port congestion was alleviated within months, but Chatterjee's ability may be limited to dealing with China's internal issues in the United States. When formulating the conversation chip bill, it showed a confusing level of professionalism. Welcome to subscribe to Silicon Dragon. We are a YouTube channel focusing on chip technology. We will bring you the latest technology information on the technology war between China and the United States. There is no need to go into details about the content of the U.S. Chip and Science Act. It mainly forces global chip manufacturers, especially TSMC, to build factories in the United States, and prohibits investment in mainland China. Regarding this provision, political websites commented that the Biden administration originally intended to solve the chip shortage problem in the short term to reduce dependence on TSMC. However, in the bill formulated by Chatterjee, it turned into a bet on American manufacturing. Moreover, the bill forces TSMC to move to the United States, which not only angers mainland China, but also becomes a political burden for the United States. But the problems with Chatterjee's chip bill don't end there. Biden signed the bill very quickly, but the bill had no effect. If chip manufacturers can successfully invest and build factories in the United States, it will be a political achievement for Biden. However, the reality is contrary to the expectations of the bill. Chip giants such as TSMC, Samsung and Intel have invested in and built factories in the United States as required, and the U.S. Congress has also approved $5.2 billion in subsidies. However, these U.S. factories have never been able to recruit enough industrial workers. Previously, TSMC's chairman complained in an interview with U.S. media that due to the lack of a large number of skilled semiconductor equipment workers at TSMC's Arizona factory, the startup of the factory may have to be delayed until 2024 or 2025. TSMC has empty factory equipment and no workers in the United States. In addition, Liu Den also made it clear that although TSMC is investing in building factories in the United States, it will be extremely difficult to replicate another TSMC in the United States. At the end of July, data released by the American Semiconductor Association also confirmed Liu Den's statement. Data show that by 2030, the number of jobs in the U.S. chip industry will increase to 115,000, but there will be as many as 67,000 vacant positions, with a vacancy rate of 58%. Regarding the practical problems exposed by the bill, Chatterjee has previously admitted that the U.S. chip industry lacks enough industrial workers. He said that everyone hopes that things will get on track, but this is easier said than done. It was at Chatterjee's suggestion that the Biden administration implemented this bill that violated the laws of market economy for nearly a year. It was only now that it was discovered that the bill not only failed to completely block China's chip industry, but instead allowed major players to the chip giant is full of complaints, and this may be an important reason for Chatterjee's resignation. According to data released by the American Chip Association, within successive U.S. governments, there are many consultants like Chatterjee who do not understand China, pretend to be China experts, and formulate China policies. The most famous one is the one who cannot even speak Chinese. Zhang Jiadan, who doesn't know how to speak, has become a guest of 4 U.S. governments thanks to street stall literature. As I said before, those who advised the U.S. government during the Cold War were geopolitical masters such as Brzezinski and Kissinger. But who are the people who advise the U.S. government now? They are charlatans like Bannon and Zhang Jiadan, and academics like Blinken and Chatterjee. This is why it is said that the strategic vision of the U.S. government is getting worse day by day. Recently, the United States, Japan and South Korea have begun joint actions to tighten the export of chips, semiconductor equipment, materials and other products, with the purpose of hindering the development of China's semiconductor industry. However, it is precisely because of their suspension of supply that Chinese scientists have been determined to conduct self-research and are breaking the relevant technology blockade one by one. Recently, China Electronics Technology Corporation, CETC, has made new breakthroughs in the field of key chip equipment and achieved complete localization of 28nm ion implanters. On June the 29th, China Electronics Technology Group announced that it had achieved full coverage of the 28nm process for ion implanters. As we all know, my country's chips have been stuck for a long time due to the lack of manufacturing equipment. We are still unable to mass-produce chips with 7nm and below processes. The recent restrictions imposed by the United States and Japan on the export of semiconductor equipment have made China's chips even worse. To put it bluntly, if the problem of semiconductor equipment cannot be solved, domestic chips will stop at 45 nanometers. So the question is, as domestic semiconductor equipment continues to make breakthroughs, how far is it from mass production of 28 nanometers chips? How important are semiconductor devices? A chip goes through hundreds or even thousands of steps, from silicon sand to finished product. Simply put, it includes acidification, purification, crystal growth, slicing, polishing, cleaning, glue coating, drying, photolithography, etching, packaging, and testing. Wait, these steps require the use of hundreds of types of equipment, among which the 9 core equipment are the most critical, in order: photolithography machine, etching machine, ion implanter, chemical vapor deposition equipment, chemical mechanical polishing machine, metal evaporation equipment, and thin film deposition equipment, cleaning equipment, testing equipment. To put it bluntly, if any of these equipments are missing, let alone manufacturing chips, the entire production line will be paralyzed. However, such important equipment is basically monopolized by the United States, Japan, and the Netherlands. Relevant data shows that in the global semiconductor equipment market, the United States accounts for 41.7%, Japan accounts for 31.1%, and the Netherlands accounts for 18.8%. The three collectively control 91.6% of the market share. Among the top 20 semiconductor equipment manufacturers in the world, the top 14 are all overseas companies. Among Chinese companies, only ASMPT and Northern Huachuan are shortlisted, ranking 15th and 18th respectively. Domestic chips are the most backward in terms of equipment. According to the saw barrel effect, semiconductor equipment is the biggest obstacle restricting the development of my country's chips. To solve the problem of stuck chips, we must first solve the problem of semiconductor equipment. With this premise in mind, let's talk about the 9 core devices. Relevant data shows that in the global semiconductor equipment market, the United States accounts for 41.7%, Japan accounts for 31.1%, and the Netherlands accounts for 18.8%. The three collectively control 91.6% of the market share. Among the top 20 semiconductor equipment manufacturers in the world, the top 14 are all overseas companies: Applied Materials of the United States, ASML of the Netherlands, Tokyo Electronics of Japan, and Lam Research of the United States are at an absolute advantage. However, only ASMPT and Northern Huachuan are shortlisted among Chinese companies, ranked 15th and 18th respectively. In other words, the entire chip field includes design, manufacturing, packaging, testing, EDA, equipment, materials, applications, etc. Domestic chips are the most backward in terms of equipment. According to the barrel effect, it can be known that semiconductor equipment is the biggest obstacle, restricting the development of my country's chips. In order to solve the problem of chip stuck neck, we must first solve the problem of semiconductor equipment. With this major premise in mind, we can talk about the 9 core devices. The first, lithography machine. The lithography machine is the core of the core, with a utilization rate of 24% in the manufacturing process. Its classification is as follows. The domestic lithography machine currently available is the 90 nanometers lithography machine produced by Shanghai Microelectronics, and the world's most advanced it is an EUV lithography machine manufactured by ASML. Calculated according to the chip manufacturing process, the difference between the two is 6 generations. Calculated according to time, the difference is 28 years. What is gratifying is that many media have reported that domestic 28 nanometers lithography machines are about to come out, and sample machines have even been produced. The 28 nanometers lithography machine uses an immersion system, which is equivalent to ASML's AFI lithography machine, but the resolution can currently only reach 28 nanometers. Its key components are all manufactured by domestic companies. Light source, built by Beijing Kihonyuan, based on the ARF excimer laser, it obtains 579 nanometers fundamental frequency light, passes through the nonlinear crystal, obtains 289.5 nanometers frequency doubled laser, and further obtains 193 nanometers tripled ultraviolet laser. Dual workbench, jointly built by Tsinghua University and Huazhou Precision Technology, it can be used for 45 nanometers and 28 nanometers immersion lithography machines. It can be used for processes below 14 nanometers and 7 nanometers after future upgrades. Immersion system, built by Zhejiang Kia Electromechanical, its precision is second only to ASML and Japan's Nikon. The temperature stability error reaches 0.001 degrees, which is in line with the international advanced level, and meets the 28 nanometers lithography technology. Optical lenses, manufactured by the Changchun Optics Machinery Institute of the Chinese Academy of Sciences, the process fully meets the requirements of the 28 nanometers lithography machine, but there is still a huge gap with size. If the 28 nanometers lithography machine breaks through, our country will be able to create a purely domestic production line with a 28 nanometers process. Don't underestimate the 28 nanometers process. Currently, 75% of the world's chips are above 28 nanometers. Only a small number of scenarios such as smartphones, supercomputers, and high-end GPUs pursue 7 nanometers or below. The value of my country's chip imports every year reaches 2.8 trillion yuan, accounting for more than 70% of global chip sales. In order to obtain this part of the profits, the United States continues to restrict and suppress China. If we raise the level of technology to a higher level, the effect of the game will be very different. Assuming that in 2025, we can build a purely domestic 7 nanometers production line, the chip game will become chip cooperation, the second etching machine. The photolithography machine is the weakest link in my country's semiconductor equipment, and the etching machine is the strongest link. Domestic etching machines have reached a replacement rate of 30%, represented by companies such as China Micro Semiconductor and Northern Huachuang. At present, the etching machines produced by China Micro Semiconductor have reached the 5 nanometers level, and the company's products have been successfully supplied to TSMC, the leading chip OEM. Being recognized by TSMC is equivalent to obtaining a global license. At present, China Micro Semiconductor has begun the research and development of 3 nanometers equipment, and is bound to win the first place in the world. However, the embarrassing thing is that China Micro Semiconductor does not have much profit, because the U.S. Department of Commerce lifted the etching machine ban against China as early as February 2015. The reason is that China has actually obtained etching equipment from Chinese companies that is equivalent to the quantity and quality of American products, and it is meaningless to continue to implement national security export control measures. After the ban was lifted, many manufacturers still chose overseas equipment means more suitable. This has also resulted in the global share of AMEC being only 1.4%. The third one is the ion implanter. During the chip manufacturing process, different types of elements need to be incorporated to change the electrical properties of the material. These elements are accelerated to a predetermined energy in the form of charged ions, and then injected into the specified material. This process requires an ion implanter to perform. The usage rate of ion implanters in chip manufacturing is only 3%, and the market share is only about $2 billion. However, without this 3%, the remaining 97% would be useless. However, in this field, American companies have won 89% of the market share, and have an absolute monopoly. Ion implanters have become the second shortcoming of domestic semiconductor equipment. Today, good news comes from SETC. The company has achieved full coverage of the 28 nanometers process for ion implanters, according to reports. SETC has continuously made breakthroughs in core technologies of key modules such as optical circuits, control, and software, forming a full range of ion implanters for medium beam, large beam, high energy, and third-generation semiconductors. The company's products can be used in the manufacturing of 28 nanometers logic devices, memory devices, power devices, sensors, etc., and the cumulative tape-out exceeds 20 million pieces. It can be said that as a newcomer and a rising star, it is very rare to be able to break through 28 nanometers. Although there is no market share, at least the stuck neck of mature processes has been solved. The fourth one is the glue coating developing machine. The glue coating developing machine is mainly used for photoresist coating and development of photolithography patterns. It uses a robotic arm to complete the photoresist coating, curing, development, film hardening and other processes of the wafer. It directly affects the subsequent exposure quality of the circuit, and also has a profound impact on etching and ion implantation. In the global market, Japan's Tokyo Electronics dominates the market, occupying 87% of the market share, and is in an absolute monopoly position. Domestic coating developing machine companies are mainly Xinyuan Micro and Shenyang Xinyuan. They have currently reached the 28 nanometers process level, and 14 nanometers equipment is in the development process. In terms of market share, Xinyuan Micro's mainland market is only 4%. It has just got rid of the stuck neck of mature technology, and is still far from leading the world. Fifth, cleaning equipment. Cleaning equipment must clean away charged ions and metal impurities from the wafer, otherwise, the yield rate of manufactured chips will drop significantly. On paper, the cleaning equipment may not look like much, but in fact it is an extremely sophisticated piece of equipment. The precision of the cleaning equipment can reach the nanometer level. 1 nanometer equals 0.000001 millimeter. What impurities will exist in the 5 nanometers gap? You can imagine the difficulty of washing these magazines. Domestic companies mainly include Shenmei Shanghai and Jichen Technology. These companies have complete industrial chains and advanced technologies, and have basically achieved 50% domestic substitution. Testing equipment. Testing equipment is one of the devices used to test the quality and performance of chips. It can detect various performance indicators such as the electrical performance and optical performance of the chip to ensure the quality and stability of the chip. Domestic substitutions include Realize Science, Jinx Electronics, Honka Fakai, and Udo. The substitution rate is 9%. Chemical mechanical polishing machine. Chemical mechanical polishing machine is one of the equipment used to flatten the surface of silicon wafers. It removes uneven parts of the silicon wafer surface through chemical reaction and mechanical friction to form a flat surface. The domestic representative company is Huihai Kinka, with a replacement rate of 20%. Chemical vapor deposition equipment. Thin film deposition equipment is one of the equipment used to manufacture thin films. It uses chemical reactions to deposit gases onto silicon wafers, forming very thin films. This film can be used to make components such as capacitors and resistors. The process is simple. The application range is wide. The equipment is simple, and the technical requirements are low, but it is polluting. Domestic representatives include Tuojing Technology, Northern Huachuang, and Shenmei Shanghai, with a replacement rate of 13%. Thin film deposition equipment. Another type of thin film deposition equipment uses physical vapor phase methods such as sputtering or evaporation to condense on the substrate in a vacuum environment to form a coating. This process has the advantages of high hardness and strength, good thermal stability, good wear resistance, stable chemical properties, low friction coefficient, dense organizational structure, etc., and is green and pollution-free. But its biggest disadvantages are the technical difficulty, high cost and complex process. Domestic substitution is mainly made by Northern Huachuan, with a substitution rate of 10%. Metal evaporation equipment. Metal evaporation equipment is one of the equipment used to manufacture metal electrodes. It uses high temperatures to evaporate metal onto a silicon wafer to form electrodes. This equipment is very important for making metal electrodes. Overall, domestic chip equipment reaches when the replacement rate reaches 80%. As long as the 28 nanometers lithography machine is conquered, a domestic 28 nanometers chip industry chain can be created, right to the end. With the breakthrough of the 28 nanometers ion implanter, only the photolithography machine has yet to break through among the 9 core equipment. According to Market News and the angry remarks of the ASML president, it can be seen that domestic 28 nanometers lithography machines are close to a breakthrough, but this is only the first step in a long march, and it is still far from full success. After all, TSMC has achieved mass production of 3 nanometers chips, while SMIC is still at the 14 nanometers stage. At the end of last year, TSMC held a 3 nanometer production and expansion ceremony at the Tainan Science Park, officially announcing the launch of 3 nanometer mass production. Previously, Samsung had announced the start of 3 nanometer process production as early as June. TSMC planned to officially mass produce in September in its original plan, but due to some reasons it was postponed to the end of the year. Today, TSMC's 3 nanometers process is progressing smoothly, and news about 2 nanometers process technology has also come out, according to reports. Nangka Chip Factory 18 is the production base of TSMC's 5 nanometer and 3 nanometer chips, and phases 5 to 9 of Chip Factory 18 are the 3 nanometer production base, according to TSMC President and co-CEO Wei Zhejia's previous statement. TSMC's N3 process progress is in line with expectations and will be mass-produced in the second half of 2022 with a good yield rate, driven by HPC, high-performance computer cluster, and smartphone-related applications. The N3 process will be stably mass-produced in 2023. On the enhanced version of the 3 nanometers process, TSMC said that its research and development results are also better than expected and will have better performance. power consumption and yield rate, and can provide complete platform support for smartphones and HPC-related applications in the 3nm era, and the N3E process is also expected to enter mass production in the second half of 2023. It has been confirmed that Apple will become the first customer of TSMC's 3nm process, and will debut this process chip on the A17 chip. At the same time, there is news that TSMC's original 3nm customer was Intel. However, due to the delay of Intel's Meteor Lake core display order, this move has greatly impacted TSMC's production expansion plan, resulting in only the first wave of customers remaining for the 3nm process from the second half of this year to next year. Apple's products include M-series chips and A17 chips. Therefore, TSMC has decided to slow down its production expansion progress to ensure the production capacity does not cause cost pressure due to excessive idleness. However, there is news that the M3 series of chips originally planned to be launched this year has also been postponed to next year. Due to the slowdown in TSMC's 3nm process, Apple will give priority to ensuring sufficient supply of A17 chips. In addition, TSMC mentioned details about the next-generation 2nm process in its annual report submitted to shareholders. TSMC's chairman said that TSMC is preparing for 2nm technology, N2, which is expected to start mass production in 2025. The process technology will be produced in Hsinchu and Taichung Science Park. 2nm technology will adopt a nanosheet transistor structure and provide full process performance and power efficiency benefits compared with N3E. N2 is 10%-15% faster at the same power consumption, or 25%-30% lower at the same speed to meet the increasing demand for energy-saving computing. TSMC also stated that N2 technology research and development is advancing in an orderly manner and will be trial-produced in 2024 and mass-produced in 2025. At the same time, the N4 process has also been put into mass production last year. TSMC also launched the N4P and N4X processes, gradually bringing more advanced technologies to each process. In the second half of this year, the N3E process with higher performance, lower power consumption and higher yield will also be mass-produced. However, only the Apple A17 chip will use the 3nm process this year, which also makes the iPhone 15 series particularly competitive this year. On the other hand, SMIC announced that it will no longer produce 14nm chips and will instead invest all its production lines in 28nm chips. Many people are speculating on the reason. Many people believe that this strategic decision was due to pressure from the United States. SMIC could not withstand such pressure, so it was forced to remove the 14nm process. Faced with the changes in SMIC's situation, foreign media gloated. The sanctions imposed by the United States had worked. This time SMIC switched from 28nm chip production to 14nm chip production. It is definitely not as feared by US sanctions as foreign media said. How could the Chinese surrender without a fight? This change is just a change of SMIC development strategy, change a different angle to break through the US technological blockade and find a new path for China's chip development. If you want to make a chip well, you must first start with the optical chip machine that manufactures the chip. This kind of machine was previously in the hands of the Dutch. The Netherlands created an ASML company to specialize in the production of optical machines. This company is not rational. It often follows the guidance of the United States and restricts the export of optical chip machines to my country. Its headquarters company is also established in the United States. It is not easy to obtain chip manufacturing machines from ASML. In this case, our country seems to have no way out from the beginning. If we start to develop photolithography machines now, it will waste a lot of time, and it may not be successful. So does SMIC really have no way out? At this time, the wisdom of the Chinese people came to the fore, and SMIC found a new way to develop. Since my country's existing technology cannot mass-produce 14 nanometers, why not produce 28 nanometers chips first? At present, 28 nanometers chips are widely used in our country, but still rely on a large amount of imports. If our country can mass-produce 28 nanometers chips, wouldn't 28 nanometers chips no longer rely on imports? SMIC saw this chip gap, and decided to switch to 28 nanometers chips. If there is still no progress in technological breakthroughs, it is better to master the technology that you are very proficient in first, and use this technology to satisfy the domestic market, and fill the gap in the domestic market. If this is done well, the scale of the enterprise will gradually increase, and the strength of the enterprise will become stronger and stronger. At this time, SMIC will have greater strength to invest in scientific research and innovation. It is difficult for foreign media to understand this kind of Chinese wisdom. They will only fabricate what they see with their own eyes, and will not understand the essence of what happened behind the scenes. What SMIC did was just a wise move, based on national conditions and domestic market demand. In the past, Huawei also used this kind of Chinese wisdom to step-by-step highlight the US blockade, and rely on the support of the country to break out of the encirclement. This is the characteristic of Chinese enterprises. They are neither arrogant nor impatient, but move forward step by step. Don't look forward or backward, focus only on the development of the enterprise, and take every step slowly, just so that one day, you can encounter the opportunity, seize it tightly, and then turn around, and you will be bright, and bright from now on. I don't know if it's a coincidence or something, but many of the world's biggest names in the chip industry are from our treasure island, Taiwan. For example, Zhang Chongmao, the founder of TSMC, first studied in the United States, wandered for many years to accumulate experience, and then returned to Taiwan to establish TSMC. There is also the founder of NVIDIA, Jensen Huang, who lived in Taiwan before he was 9 years old. I just came to the United States and started studying. Even Zhang Rujing, the founder of SMIC, was born and raised in Taiwan province. During the Liberation War, Zhang Rujing's father took the 1-year-old Zhang Rujing across the Taiwan Strait to settle in Taiwan. Now, Zhang Rujing has switched jobs from SMIC to Shanghai Jita Corporation, with a passion to serve the country, and is committed to making new contributions to our country's chip industry. In fact, Zhang Rujing like this is inseparable from the teachings of his father Zhang Zilan. Zhang Zilan was a senior employee of the Kuomintang military factory during the Liberation War. His daily job was to make steel and make weapons, and he was very patient with his apprentices. It was under his words and deeds that Zhang Rujing had such great ambitions as he does today. Nowadays, Chinese are not uncommon among those who have laid the foundation for chip development, but most of these Chinese are committed to the development of American chips in the United States. We can't complain about them even if their positions are different. But one thing is that the Chinese are by no means incompetent. The Chinese will definitely be able to create their own chips, now that our country is under a technological blockade by the United States. Coupled with its late start, we may not be able to achieve very high achievements in the chip industry in a short period of time, but I believe that one day the Chinese will be able to break through the technical barriers of the United States and create unique Chinese chips. Thank you very much for watching, and we hope the information we have provided will be helpful to you. If you have cutting-edge information you would like to know, please leave us a message.